Now, let us start with the practice exercise for the third part of Topic 2. In this part, we study the method of designing a program using functions or subroutines. Then, as a summary of the whole Topic 2, we discussed an algorithm doing cryptanalysis of ciphertext created by Caesar cipher. So, as a project practice exercise, in a final project, Project 5, we will be challenging ourselves to cryptanalysis. Let us first consider this problem. Define the encryption function and the decryption function for Caesar cipher, or more precisely, implement them as Ruby subroutines, and then create programs using those subroutines. This is a general picture of cryptographic communications. Then, these are functions that are asked by the problem. Well, these are mathematical functions specifying the goal of each computation. For example, this enc, given a pair of a key, and that is a shift number, and the plain text, we want to compute the ciphertext for this plain text by shifting k letters. This function enc specifies this task. Similarly, this function dec specifies the decryption task. What we need to create is subroutines realizing these computational tasks. But since we have already created a program for encryption, the subroutine implementation is not so difficult. You can simply convert it in this way. Let me explain first the whole structure. In Ruby, the definition of the subroutine always starts with def, which is followed by the subroutine name and the tuple of arguments. In our case, enc, is the name and its arguments are k and m. By the way, the definition of subroutine is given between this def statement and the corresponding end statement. In this example, this is the end statement, so the whole of this box is the definition of subroutine enc. Once subroutine is defined in this way, it can be used like a standard function in Ruby. I will explain this later. Now consider the body of the subroutine. The computation itself is exactly the same as here. The difference is indicated by blue fonts here. First, in this side, we had to set k and read m. But in this side, since it receives k and m as an argument, there is no need to set k nor read to m in. Another difference is this return command. In a program, the standard way to report obtained result is to output it on the screen. So we have an output command like this. Here, on the other hand, a subroutine usually reports the result as a function value. The return command does this task. When execution of the subroutine reaches to this return command, the execution will go back to the place where the subroutine is used as a function. At that time, the value stated here is reported as the value of the function. In this example, the value of this string variable c, that is the computed ciphertext, becomes the value of the function enc. This is the definition of the subroutine enc. Next, consider the subroutine realizing the decryption. Since we have the definition of the subroutine for encryption, defining the one for decryption is not so difficult. The subroutine for decryption is defined like this. Let us call it dec. You see, enc and dec are quite similar. Again, I use blue characters to identify the different points. They are mainly the changes of variable names. The essential difference is this one, the minus k shift operation achieving the reverse shift for decryption, recovering the original plain text from the ciphertext. We will consider this at the actual programming. Now that we are able to define these two subroutines, we can easily create programs using them for encryption and decryption. Let us name each of these as encrypt.rb and decrypt.rb. Here are these two programs. Let us see the encryption program, encrypt.rb. This part is for the definition of the subroutine enc. Then, this is the main part of the program. In fact, the execution of this whole program would start from this line. The first line after the definition of a subroutine. Here, we set the variable k and read in a plain text to the string variable plain text. Next, we call the function enc with these arguments. Then, the computer executes what is written in the subroutine with these arguments passed to the variable k and the variable m here. Then, when the execution reaches to this return command, the computation comes back to this point with c as the value of this function. Well, this is what happens in the computer. On the other hand, you may simply consider this as a standard function, and this is the value of the function enc on these arguments. This is how a subroutine is actually used in a program. Okay? Well, assuming that we design the subroutine appropriately, this value should be ciphertext corresponding to the plain text under the shift number k. So the program ends by reporting this ciphertext to the user or showing it on the screen. The program decrypt.rb has a similar structure. Now these programs are executed like this. First, the program encrypt.rb is executed. Here, the redirection is used. So the input data to the program, that is the plain text, is given from the file message.txt, which was prepared before. Then its output, that is the ciphertext, is kept in the file cryptmessage.txt. In the second line, we execute the decryption program decrypt.rb, where the input is given from the file cryptmessage.txt created above. This time, we let the computer output the result on the screen. So this is the original message, original plain text message decrypted by this program. This is how you can use these programs. Okay, now let's move on to the actual programming.